Hey everybody, how you doing? This is Larry. I'm going to compete in the Leetcode Weekly Contest 171. Hope everyone's having a good night. I have 35 seconds left. Uh, yeah, I did okay earlier today. Hopefully tonight I'll continue to keep that up or at least do better or not do too poorly. Yeah, and let me know what you think in the comments. Hit the like button if you like it. Hit the subscribe button if you want to see more. I've uh, been doing this for a bit, so yeah. Let me know how you feel and hope y'all are having a good day. And here we go. 5 seconds. Cool. Opening problems. I need a theme song for opening problems. I feel like I say that a lot. But yeah, this one, I think I actually misread this at the very beginning because I just thought that you just have to return its answer that's not zero. But I was like looking at the examples, and luckily this one has a lot of more examples with an explanation even. So I was like, okay, now that's. I think the thing that kind of tricky about this one for me anyway is that this is one of those problems that I think has some. I mean, maybe it doesn't pan out, and it's just me. Is that for some people might be like a little bit of a reverse trap because like let's say you're beginner, you don't know other algorithms, so you might just kind of do the brute force wing, right? But for me, because it's mathematical and I'm always scared about math problems, maybe I didn't know whether immediately if I could prove that one of the answer has to be between 1 and n, right? Like maybe, I mean, and this is clearly not the case here. Well, I mean, I don't know if it's that clear, but it's not the case here. But you can imagine, like, hey, maybe you need negative numbers to make it right? So I don't know. So I didn't, wasn't super confident. That kind of made me kind of really make sure on my testing, that's why I was a little bit slower than I would like on this one. But not, I mean, overall, like, I'm like if you look at me typing, I'm not actually like typing that fast either. So I think I'm just a little bit rusty, not as warmed up as I would like. But and also see if you could spot the Python bug. That is unfortunate. That cost me maybe not a minute and a half. And that minute and a half actually turns out to be a lot on the rankings because everyone end up solving this pretty, well, not everyone, but like everyone in my target range did end up solving it very quickly. Um, but yeah, but luckily, I looked at the last one. I'm like, huh, this is the wrong answer, which is good. Because what you don't want is to submit it and then get a wrong answer. But what happened was that bug that I was talking about in Python, because and some of that is just being, I don't know, a little bit rusty. Maybe I've been changing languages too often lately. I've been playing around with Java and C++ in various different places, and certain language nuances does come into play here. See if you can spot it. And I was like, huh, that should return false, but it is returning true. And this cost me a few minutes. I don't know. You'll laugh, I'll cry when you spot this. Just iced tea, by the way, not anything alcoholic, in case you're wondering. I mean, I had to do 2 levels to. Also, I think I clicked on it and didn't click, but that's what I remember. But I looked at this. I think it still didn't occur to me yet where it was. I just wanted to isolate it. I think that should have been a red flag. I'm like, huh, what is going on? And I'm like, why is there fractions? I'm like, oh my, what silliness. I mean, I feel like I was more confident about being right that time. Uh, yeah, and then as soon as I saw that I submit, to be honest, still a little bit unsure. You could see him out of his face. But once it accepted, I'm moving on. Silliness. Moving on to problem 2. This one I also I was a little bit slower on, but I knew how to do it immediately because it's just a sort of greedy. I think I'm also misread. I think I didn't. I need to. I think one thing I needed to do is read the problem a little bit more carefully. I think initially, I've been practicing obviously, but but because of that, you see similar problems and you're just thinking about different things. And for me, excuse me, my initial thought was that you have to flip a number of bits such that either A, you flip to make A equal to C, or B equal to C. So I think that cost me a little bit in terms of just like mental thinking about it. Uh, but then I was like, oh, as soon as I was like, oh yeah, actually now that you read it correctly, Larry, uh, you know how to do this. But as you can kind of tell, I'm still like not very decisive about it. I think I'm working out the exact logic in my head just in case. I was a little bit slower because I was thinking about the edge cases and wanting to kind of, I mean, I think at my skill level per se, at least right now in terms of my current rustiness or whatever you want to call it, I want to focus on not giving away 5 minutes of wrong answers, right? I've been doing that a little bit too often lately, where like I got 99% of the problem, but then that 1% cost me 5 minutes per incorrect submission. So yeah, and that lack of planning shows here because now I kind of do this, and then I was thinking, yeah, but generally I was just really working out the logic bit by bit, and probably could have done this with bit operators. Maybe that would be cooler and more fancy, but we're doing the same thing essentially. But I did want to keep it consistent. I didn't want to like do one thing in one place and then see right there, do another in another place. But yeah, so you're gonna see a little bit of a either a typo or minor like just lapse in thinking in the maybe even now, right? So see if you can spot it. Comment below, see if you noticed it before I pointed out or fix it. There you go. That's one. But yeah. I'm like, okay. So basically, I don't know if I looked at the test case, but that was something that was in my mind, like the sample test cases where if A or B is bigger than C, you might not take into account because you have some leftover ones, right, to make it into zeros. And that's something that I was definitely very mindful of, just because I was like, that seems like the type of silly mistake that Larry would make. So I definitely wanted to check for it, and I did add slowly adding the test cases. And I think right then I checked to see if there was a case where A or B is bigger than C, and there wasn't. So I was like, okay, I have to check for this. Let's run this. I was very surprised to see that being wrong, so I was like,
It's very slow again.
To be honest, yeah, I mean, I was pretty surprised. Like, maybe there's a thing where like only A or B equals Z, and I was like, wait, that doesn't make sense. I don't think that's right at all. Let's try 7-0 so that like I don't know. I don't know what I was trying. But the good thing is, good in the debugging sense, it was still wrong in a very clear way. So I was like, okay, something is wrong. So I mean, this ended up costing me a minute or two, which in the real world is not a big deal, but for these kind of really fast contests, it's a little bit slow. Yeah, and that was it. I don't know. Like I think I was I think I have some mental tempo in my head, and then I was like, okay, yeah, might as well just test the other one. I mean, this testing loop is a little slow. It always feels a little slow when you're waiting for the answer because you're like almost there, and this end up taking about 10 seconds, and like an extra couple of seconds just reading the answer. Right, it's good. I'm moving right on. Yes. Okay, problem C. So yeah, here I think I think so. For me personally, I looked at it. I was like, okay. I skipped the problem and looked at the examples, but then I was like, okay, Larry, read the problem first. So I forced myself to read through the problem a little bit because I've been making that kind of mistakes a lot lately. And I think my immediate thought is trying to figure out whether I think for me right this moment I knew what to do roughly. It essentially boils down to a sort of connect the components and some math around that. But I I think right now I was just, oh yeah, and I double see the edge because something like I saw the n is equal to or less than 10 to the fifth, but then if you have, so like if you have a, even if you have a v plus g algorithm, you know that there'll be like n square, roughly n square edges, but that second criteria means that there are at most 10 to the fifth edges, so I didn't have to worry about anything that's v plus g. And I think I did spend some mental debate on whether to use union find or breadth first search or depth first search. I was thinking about using depth first search, but I was like, 10 to the fifth with Python. At least, I mean, I should test this offline, but I was just worried about Stack Overflow and stuff like this. That's why I end up using a breadth first search. I converted the input into an adjacency list, so that we guarantee that we proceed. I just want to make sure that the input is what I assume it is. I didn't really need to see this, I think, but or like not immediately. I should have kept on typing. So some optimizations there. I just wanted to confirm the bottom, and I'm like, okay, let's just do this. Let's go. Yeah, and I think it seems like looking back, I was very indecisive about what I really wanted to do, and I think that's where it cost me a little bit of time here and there. Um, I think right now I was thinking whether I need a global scene or like a regular breadth search where um, like you reset the state on every actual top level search. So it's yeah, uh, and this is very standard kind of connected components code to be honest. So I probably should and could do this a little bit faster, though it is what it is. And that's just counting the number of components. I was doing some math here. I was like, oh wait, what is the case where uh, we return -1, right? So I was just thinking about that. I think it's obvious to someone whom knows the answer. I was just wanted to be really precise about it. That's all, because I worried about off by one, so that's why I was very slow. You see me typing character by character actually really slowly, but I mean, because you knew that for n edge or n nodes, you need n-1 edges. So yeah, that's essentially what I did. But I just wanted to be really precise. And I also wanted to in this case, I wanted to terminate early before I do the breadth first search, just for performance sake. And this is probably Leetcode specific, because Leetcode is the only place where all the test cases are ran together, versus each one has its own time. So for that reason, even though like it doesn't really change, like for one test case, it wasn't going to make it like slower. But I just wanted to make sure. I mean, it's not a big deal to move the if statement up right for a retermination, so that's why. But it probably doesn't impact things. But that was my thought, in case you wanted to know. But otherwise, this is standard breadth first search. Oh yeah, the only caveat is that I didn't want to use Q or Dex, which is a cleaner Q in Python. So I ended up using a stack for the astute Python person. So this is actually technically speaking depth first search, but because we don't have to worry about distance, it's just connect the components. It doesn't really matter. And here I think I was pretty much done, and then now I'm thinking about well, thinking about running the code apparently. I just really want to be careful here. The testing cost me a minute, so I guess maybe I could be more confident, but I was also like, okay, if I get this right, then I'm going, right? But I think for this one, to be honest, I was relatively confident in terms of algorithm and stuff like this. I think the only thing that I was testing for is maybe a typo or not, because I've been having a lot of those lately, to be honest. And especially in Python is a little bit trickier because, just because it compiles doesn't mean, because of the type system. So there's even less confidence there. Yeah, as soon as the answer shows up, I was like, okay, double checking, looks good, that's good, submit. Fingers crossed, let's do it. Okay, yes. Another problem. Minimum distance to type a word using 2 fingers. Yeah. So I solved this. So immediately I think, well, I mean, I was just reading it to be correct because this is a weird keyboard. I was reading the distance. I think immediately I had 2 dots. One was dynamic programming. The other is Dijkstra's algorithm. Guess both really worked here. You do the math on kind of the bounds, which is 26 squared times 300. You're mostly okay either way you go. I mean, I think DP is actually technically slightly faster because you don't have to deal with heap sort on the states, but then with the heaps, okay. But then yeah, with the heaps, you don't always have to reach every state, and also. Yeah, I mean, I guess you could have gone top-down memorization, but and that stack length would only be only 300. But I wasn't to be honest, I did not think about that during the contest. That's why I'm thinking about it now. But you could have definitely done dynamic programming, and maybe that's actually now that I look at the leaderboard and times, that's probably the way quicker solution to type up because you just try for all beginning 2 fingers and then you just gotta calculate the distance, and because you always progress one letter at a time, there's always going to be a DAG. Oh well, so I did learn, think in retrospect, but it's okay. Yeah, and now I'm just presetting the heap. I don't think there's anything surprising for the rest of this. I think I mostly got this in the first go. Unfortunately, I think there was a lot of typing and a lot of thinking a little bit. So I think that's why it's a little bit slow. And there was a little bit of copy and paste that I really wanted to make sure that my edge cases were right and also that the copy and paste is correct and fixing the copy and paste. But thinking about it now, I think the easier implementation would have been dynamic programming. Oh yeah, the one thing that I did want to do is cache the distance so that we don't calculate the distance every time. That's about it. This is a little bit slow, but yeah, nothing really that crazy about it. I think I do some optimization and do some lookups, but otherwise the rest of this problem reduces at least the way I implemented was distro with a heap, with repeated relaxations kind of thing. Um, that was just a trick, but yeah, cool. All right, I'll see y'all on the other side. I don't have that much to add to this problem. Definitely, you know, use the links below to kind of skip ahead. At some point the links will also contain a write up of the explanations. Feel free to kind of let me know what you think. Cool. All right. See the other Larry later. Whew, okay. Where did I finish? I was in 10 minutes, geez. Wow, people are really fast. I was kind of slow on that one, actually. And it wasn't maybe the third one. But, wow, people are really fast. I mean, I thought I was okay. I just kind of, there's a lot of typing the way I did it. Maybe I could have typed less. First, but yeah, let's go over these problems. Probably could, I mean, definitely could have been faster, but not, I'm not going to feel bad. Oh, 61st. I mean, no errors, pretty okay. 2 seconds. So if I didn't test that one extra time, it would have been slightly higher. But that's not a big deal. I mean, that's not realistic. I think on my mind is trying to figure out how to be a little faster, because I think I knew how to do each of these, but I wasn't really fast about it. Okay, let's go over the problems. First one. Yeah, I mean, to be honest, well, I mean, I had a silly mistake with just Python. I mean, maybe some of it is that me, I've been changing around languages, so obviously, I just cost like maybe a minute, which is unfortunate, but it's fine. I mean, 3 minutes for this one is probably a little bit long, but I also feel like, I don't know. I think this is one of those problems where like if you're just confident and you go for it, and maybe because there's a little bit matter about it being easy, then you could just do it. For me, these kind of problems, especially with these kind of analysis and math and stuff, and let's say you have no idea the difficulty because it's not marked as easy. Like it would take, and it did even during where it would take me some time to convince myself that like the naive algorithm is right. Like I don't know, maybe it's very obvious to some people, but for me, I would have to prove it. But otherwise, I mean, the way I end up doing, and I still didn't prove it, it's just I do it, and that because it's not clear to me that there's always a solution from 1 to n, or one number being, a number from 1 to n. Like I don't know, we had to go into negative numbers, but yeah, and also I just didn't. So I don't know. So that's why I was a little bit slow on this one. But once I was like, yeah, that's probably the way to do it. Then that's the way I did it. So yeah. Minimum flips to make A or B go to 0. This one I was a little bit careful on. People were fast anyway. To be honest, I have to kind of see how I end up taking 5 minutes. I knew how. I think I didn't really understand this problem very correctly. Like this maybe should have been like a bitwise or well, I mean it mentions it, but like I think I just didn't get it very quickly. And I was trying to be slower a little bit to be deliberate, but probably a little bit too slow. And also I had a typo here that kind of maybe cost me a minute or two, because I mean, but it's a good thing that I did spend extra time testing because that caught that bug, right? Because I was definitely wrong. Like I knew in my head what I wanted to do, but I got the digits flipped up with the 0 and the 1s. But otherwise, yeah, just very greedy, one bit at a time. I'm not even greedy, just, well, I mean, maybe it's greedy. I don't know. People are calling everything greedy these days. But just one bit at a time, flip, like, if it's one, then if it's one, then as long as one of them is one, then we don't do anything. If they're both zeros, then we just flip one of them to one, so we count it. Otherwise, if it's 0, then we just count how many we have to flip to 0. And then at the end, we have to get the leading bits, which was something that I wonder if there's an easier way to kind of do this math, because people are really fast. But what I worried about was, I worried about just like this case. So I was intentionally a little bit slower or deliberate about it. But yeah, that's the second problem. The third problem, yeah, I mean, I guess in my mind, I end up taking 7 minutes, which, well, which is a little bit slower than, and I mean, I also, my caveat is that as you kind of see from the stream, I don't, whatchamacallit, I don't copy and paste code in. I think this would be one where that's a case where that could happen, if only because it's connected components. So there are a couple of ways to do connected components, breadth first search, depth first search. I end up doing a breadth first, well, I call it a breadth first search, but technically it's a depth first search because I use a stack. But but if I had, but the other way is union find, which I was like, I didn't really want to implement union find right now. That's something that maybe I could practice on. But if I had a copy and paste code and I could just copy and paste in, then like the rest of the code is basically like 3 lines of code or something like that. So I could have gotten this really fast in theory, but that's okay. I think it's a tricky thing because I think I want to practice on typing as well. But that said, I'm not practicing the stuff that I'm weaker on, which is union find, obviously in this case. So that's something that I have to think about maybe afterwards, what my goals are. But in either case, yeah, the number of edges don't really matter, or like it matters at the end, but it doesn't matter which particular one you use to connect the new ones. Just connect the components, and if and you just want to connect them in such a way to yeah. So if you have enough cables, if you don't have enough cables as -1, and you could check that because you just don't have enough cables around, which is what I have here. But if you did, then you would just see the number of connected components. Then you require one cable moving from anywhere. It doesn't really matter where, because if you have enough cables, that means there's a loop somewhere anyway. So you could take one of those cables and then connect them for each of the ones. So then that's just the number of connected component -1. So that's C. And yeah, so that's kind of how I did it. And then D, yeah, I mean, this was yeah, I use Dijkstra's algorithm pretty much directly. I don't know if there's a slightly quicker algorithm, but I quickly pulled out the calculator to count the number of states. It was good. It was like 26 square, one for each finger, and then times 300. I think I was a little bit slow in the typing because I was a little bit. I think as soon as I saw this, I knew how to do it. I think what I was focused on is not doing something stupid, and there is a little bit of copy and paste here, so I was a little bit careful. But otherwise, I think this was actually pretty straightforward, and I probably could have or should have done this a little bit faster. But I'm okay with that. So where did I end up? 61st. I think this actually counts the other server because like John Cram is here, and he's usually on the other server. So maybe that's not so bad if that's the final rank. Wish I finished top 50 though. Let's see how close was I. 50, a minute and a half. I probably there are a lot of places I could make an improvement on. I mean, overall, I think this problem set, I thought that I was just trying to be careful, and I thought that there may be some edge case-y stuff, so that's why I was a little bit slower. But I'm okay with that. I think probably maybe I could have been like 2-3 minutes faster, but I don't, nothing that much faster. People were really quick on this contest. It seems like, I mean, 21 minutes, or 10 minutes really, but with 2 silly mistakes. Which is what I try to avoid, but still faster than me. So that's that's hilarious. But yeah, I probably should have gotten that faster though, because it seems like people got that really fast. I mean, I knew what to do immediately. I just knew that I have to focus on not getting it wrong. I think that'll be for the next section where I look at people's code, because 50 lines of code is maybe a little bit much. Maybe there's ways to concise it, or maybe I could just type faster. I don't know, but cool. See you in the next section. What up? So yeah, code review portion. This is the portion, in case you're new, where I try to review my code and compare it to other top competitors, and then see where I can improve and learn better. I mean, look at this. 17 minutes is ridiculous, and even just like more moderate, top 10 is like 10 minutes of improvement, right? So let's see where I could have done better. I think the first one I just kind of have some issues reading, but I just wasn't also, yeah, okay, the Python stuff is a little weird, but anyway, I took 3 minutes, but oh, okay, that makes sense. I mean, it's essentially what I did, but in a way smarter way, which is do it with the string. That makes sense. I mean, less margin of error. Like we don't have to write a while loop is easier, and there's also just like lines of code, and it was going to be fast enough. Again, if you saw my earlier thing, then you might not. Like I think the tricky thing is convincing myself that this is correct. But overall, anyway, not a bad point. I mean, not a tough thing to do in either case. I just didn't do it. Let's see. Question 2. Oh yeah, this is also the bitwise or. I definitely could have done this one faster. Okay. I mean, same idea, but mapped it to an array so that they just do an array one at a time, so you don't have to deal with. And also by throwing it to 32, you don't have to do the weird like HKC thing that I did. But yeah, I mean, definitely cleaner and faster to write. Oof. I mean, same idea, but this would have been harder for me to kind of, I don't know, to come up with. Bitwise stuff is tough. But yeah, I mean, this is definitely clear. Oh, that's the smarter thing I should have done, the I loop. Um, so the same thing that I was talking about, which is to get rid of these while loops, would have been cleaner, which is the for loop from 1 to 30, which I did earlier on the Code Force contest actually, but or like yesterday, but didn't do it here, so definitely a little bit more practice. But yeah, not too bad. I mean, I still got pretty okay, but definitely feel way faster. The third one was to connect components. What I imagine seeing is that people have very quick union find. Yeah, exactly. Union find implementations that I copy and paste, and then it's just like 3-4 lines of code from that. Yeah, union find, and here is even well, okay, with path compression, but linear otherwise. Yeah, everyone did a union find. I should have. Yeah, I think so one thing I don't do is I don't copy and paste code in. But I guess I need to practice more because this is like 3 lines of code. I could have done that, and then everything else was straightforward. Because you could do it live with the connections in that case even. So, but oh well. Yeah, everyone did union find. I guess I probably am the only one that didn't do union find, which is not surprising. I could have done better about that. Yeah. I mean, this was okay, not this one, but the one that I just saw was like 5 lines of code. I need to compress that a little bit in my head, and just more practice in general. I think some of that was that I wasn't confident about it. Here's a beloved fellow BFSer. Still got a very good time. So yeah, cool. And then now the hard, I took way too long. What I imagine seeing, I mean, I think my code is pretty clean for what it is, but I imagine there will be dynamic programming with caching, especially anyways, probably doing it. Let me see. Yeah, see, caching and then everything is dynamic programming. Yeah, that's looking back, that's the way I should have done it. Um, but and no, didn't even need to cache the distance formula, or maybe no, he didn't. I did, but he did not. But well, cache the area, the location. So I guess that's close enough. But yeah, definitely something that I could have done. Dun, 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 dun. But yeah, no worries. I mean, different edge cases, dynamic programming again. Yeah, and okay. So I guess most of the faster ones are dynamic programming, just because it's less to write and also like much clearer. Um, but I end up doing Dijkstra. But yeah, well, it is what it is. Yeah, overall not bad. Maybe I'm one of the faster Dijkstra ones, but It doesn't matter when everyone else is doing dynamic programming in like 10 minutes or less than 10 minutes even. But yeah, cool. Overall, yeah, anytime you finish in top 100, I have to be thankful and grateful, and that luck is a little bit on my side, even if I got beaten by 18 minutes. But yeah, overall good contest. My best contest of the decade. Looking forward to doing more. And if you're still here and you like this video, hit the like button, hit the subscribe button, tell your friends, and link it around. I don't know. But anyway, have a good night. Yeah.